Hi guys, welcome to the second video in this series. We're looking at question 9 from the calculator paper. This was a question that required an explanation. So whenever you see these dotted lines, it means that you need to write a sentence. Don't just put maths down here. You can put some working down here, that's fine, but you need to be explaining. That means using a sentence. So pause the video, remind yourself of it. And okay, so let's have a look. The nth term of a sequence is 3n plus 4. That means if we were looking for, let's say, the fourth term of the sequence, it would be 3 lots of 4 plus 4. So let's start to form this sequence and have a look at it. So we've got 3 lots of n plus 4. So if n was 1, if we were looking for the first term, we would go, okay, n equals 1. So the first term is going to be 3 lots of 1 plus 4. So 3 lots of 1 is 3, plus 4 gives us 7. So if we're looking for the second term, we would go n equals 2. 3 lots of 2 plus 4 would give us, well, 6 plus 4 gives us 10. Just looking at those two, you can see that the plus 4 remains the same. The only thing that changes is the number of 3's. And we can see that that's reflected in here. We see that 7 has gone up by 3 to get to 10. So we can kind of use that to figure out the next couple of terms. We can go, okay, well, the next one should be 13. Should we figure that out? If n is 3, 3 times 3 is 9, plus 4 does give us 13. Excellent. So I can just keep on adding 3. 16, 19, 22. Okay, so we can see that 21 is not in this sequence. It's not 19, and then the next term is 22. So that was enough. To answer that question, we could have said the 1, 2, 3, 4, fifth term in the sequence is 19. The sixth is 22. Because 21 is between these numbers, it is not in the sequence. Okay. Another way to solve this, if you are feeling confident with your algebra, another way to solve this is to use algebra. So what it's asking us really is there an n so that 3n plus 4 gives us 21? Well, 3n plus 4 is 21, so 3n equals 17, and that gives us n equals 17 over 3, which you could work out on your calculator. You don't really need to. All you need to know is that that's not a whole number. 17 isn't in the 3 times table. So how do you write this? How do you explain this? You would show that working, and then you would also say 3n plus 4 equals 21. Whoopsie. Does not have an integer solution. That means we can't find a whole number for which 3 lots of n plus 4 gives us 21. And we know when we're dealing with a sequence, you can't have the 1.5 term of a sequence. You can't have the, it has to be a whole number. So there are 2 ways of answering that part. This second part says, here are the first 3 terms of a different sequence. Write down 2 numbers that could be fourth and fifth term of this sequence, give the rule that you use to get to your numbers. So most of you got this right. There were two kind of obvious solutions. I don't know if anyone came up with any others. The first one is to notice that the term is doubling each time. So the next terms would be 8 and 16. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. I doubled each term to give the next term. Okay, another one which was possibly harder to explain was to notice that, okay, what's being added each time? That is +1. That is +2. So the next term I would get by adding 3, which would give me 4 plus 3 gives me 7, and 4 plus 4 gives me, 7 plus 4 gives me 11. Okay, it's really good to show this, how you're getting the next term, so that helps with your explanation. So you could write something like, the difference increases by 1 each time. For example, the difference between the first two terms is 1. The difference between the second and third terms is 2, etc. Okay. Alright, so hopefully that was useful for you, and keep watching, there's more to come.